Hello everyone, welcome back to the series. In the last video, we clearly understand how polysilicon is made from quartz through multiple chemical process to ultra pure silicon. And today we are going to move the next important stage. So how the polysilicon is converted into silicon ingots and then into wafers. Why are ingots and wafers are needed here? So because of solar cells are not made by directly by polysilicon chunks. So they are made from the silicon wafers. How to convert polysilicon to the wafers? So we learn here. So let's break down step by step in the simple way. So step one is loading the polysilicon. This is the first step. So we begin with high purity polysilicon pieces. No? These are carefully placed inside the quartz crucible. You can see the quartz crucible. So think of this like loading the raw material into the furnace before melting. So why? Because why we are doing these all things? Polysilicon is our base material, right? But it cannot be directly shaped. So first we need to convert into liquid form. The step two is melting process. So we are converting solid into liquid. So now the crucible is heated to around 1414 degrees, which is the melting point of silicon. You can see the image. At this stage, the solid polysilicon becomes molten silicon. It's like a liquid form. So just like I will give you some example, just like ice can melt into water, like in the temperature of minimum temperature. But here the for silicon around 14 degrees it will take to melt. But it's like a very high temperature. Why we are converting liquid? Because of liquids can be reshaped, but solids we cannot reshape, no? So that is the reason we are converting into liquid, and this liquid is hotter than lava. So next step is doping. Doping means nothing but we are adding some ingredients on the this liquid. So like a boron so makes p type silicon, and phosphorus makes n type silicon. We are adding the both. So why we are adding? It controls how electricity flow in silicon, and it makes silicon useful for cells. So here na without doping, silicon cannot function properly in solar application. Without doping anything, we can't do the solar cell. So that's what we are doing here, adding small ingredients that completely changes behavior of the wafer. That's it. So next is step 4. It is called crystal growth. Like we are forming the ingot formation. This is called as a CJ process also. See, a small seed is there. Now you can see the seed. There is a blue color that is called as a seed. What the seed is do? It pull the upward whatever the atoms is there. Na, they are attached to the seed, and they will arrange in the same structure. So then it becomes a like ingot. I think you're feeling like a confusion. See, so what is happening here? Atoms are follow the pattern. So of the seed crystal, you can see the seed crystal. So forming a single continuous crystal structure here. That's it. So this is called as a monocrystalline silicon ingot. We see the image, na? It is form a single long cylindrical solid format. See. So what is happening in this process? I will give an example. Basically, honey. Think of pulling honey with a spoon, and as you lift like very slowly, then it creates a stretches, na, like a smooth stretches, just like a silicon forming a crystal ingot here. That is. So it's control the pulling gives a uniform structure. Or else you can simply say there is a dipping stick in melted chocolate, and you can pulling the out like very slowly, then it coating very like forms evenly. The similar how silicon grows into a crystal ingot here. So next step is cooling. This is step 5. So once the ingot is formed, so it is cooled like very carefully. So cooling is must be controlled by the very big professionals. Why? Because if you done the sudden cooling, na, it creates the cracks. It's like very costly. This ingot is. It can create defects in crystal also. So there is proper cooling. It ensures. for the high quality silicon structure. If you see the before picture, it looks like a reddish color. So right now in this image, the ingot is completely cooled down. So after this step, the ingot will move to the ingot shaping. So the ingot is currently looks like a cylindrical in shape, but solar wafers are usually like a square and rectangular. So what they are doing here, they will cut the sides of ingot. So this process is called as a squaring. So why they are doing here, like better space utilization in solar panels, and it reduces the energy loss, and it gives the packing efficiency. So for the next step is a wafer slicing. It's nothing but it's creating the thin sheets. So the ingot is sliced into the very thin pieces. So by using of wire saw machine, you can see the wire saw machine. So it's like here thickness is almost 150 to 180 microns, and so after cutting these ingot, the wafers are not perfect. So they go through the like chemical cleaning, and why? Because it removes the damage and impurities, and they will do the surface texturing. So it's create a like a tinny pyramid structure. You can see the tinny pyramid structures. Why they are texturing using here, like it's reduced the light refraction, and it gives a better efficiency, and it increases the light absorption also. In a later on video I will tell you while in cell process. So the first step is texturing only in the cell process. So basically here they will not do basically in the cell process only they will do the texturing. So this is the entire steps. So these wafers are base material for the solar cells. I will tell you the entire process once. What we are doing here. First we are converting polysilicon into a crystal ingot. Then we slice into the thin wafers. See, you can see the image, you might get some clarity. And these wafers are used to make solar cells. That's what we are doing here. So we have the polysilicon, and it will be melt, and it grows the crystal, then it forms the ingot, right? Then ingot, it will cut the slices, and after what will happen, like a cleaning, then we got the wafer. That's it. Very simple, like solid, liquid, crystal, and thin shades. That's it. In the next video we will see the how wafers are converted into solar cells. So thanks for watching. See you in the next video. Thank you.